Okay, this is your mole exam review. Let's start with station 1A. What is the percent composition for copper and sulfur and copper 2 sulfate? First, you have to know the formula for copper 2 sulfate, and it's right over here, right there. Oops, I erased it. So it's CuSO4, and its molar mass is that right there. So we want to figure out the percent composition for copper first. So we have to take the molar mass for copper and put it over the total, which is 159.61. That's the mass of the copper 2 sulfate. And when we do that, we get a number that looks kind of like the 63.55 divided by 159.61. That equals 0.398 multiplied by 100. You get 39.8%. And for the sulfur, 32.06, which is the molar mass for sulfur, divided by 159.61, the total, and we get 0.200 times 100 gives us an answer of 20.0% for the sulfur. Okay, pretty simple. How many atoms in 59.6 grams sample of tin? You need to know the molar mass for tin, and there it is. We start with our 59.6 grams of it, and we're trying to find atoms, so we have to go through the mole to do this. So here's where our molar mass comes in, or 1 mole. That's what we do in our flow chart. And the second part of this two-step problem is we put 6.02 times 10 to the 23rd on there, and we're looking for atoms over here. So when you multiply the top two numbers together, and then divide by the bottom number. And when we do this, 59.6 times 6.02 second EE23 equals, divided by 118.7 is 3.02 times 10 to the 23 atoms. And we box our answer. Okay. Looking for the moles in 36.4 gram sample of magnesium chloride. There is the formula for magnesium chloride, MgCl2. Here is the molar mass for that. So we start with our mass, 36.4 grams. We're looking for moles. Okay, and so we need our molar mass of MgCl2. And now we simply divide the two numbers together because they're diagonal. 36.4 divided by 93.92 equals, and we get the answer 0.388 moles. Empirical formula of a compound is C2H3O. What is the molecular formula if the molecular mass of the compound is 215.2 grams per mole? First, we've got to get the empirical formula for that. The molecular weight for that. Empirical weight. So here it is right there, 43.04 grams per mole. So what we're going to do is take our molecular weight, 215.2 grams per mole, and divide it by 43.04 grams per mole, and we're going to get the answer that looks like that, number 5. So we take that and we set up our last step of the problem, which is take our empirical formula, put it in parentheses, and put that 5 on the outside. That says to multiply everything on the inside of that parentheses by 5. So C is going to be C10, hydrogen is going to be H15, and oxygen is going to be O5, and that's your empirical formula of the problem. A hot air balloon contains 2.58 times 10 to the third liters of helium at STP. How many helium atoms are in the balloon? Okay, set it up again. We're looking for atoms here. And we have liters over here, 2.58 times 10 to the third liters. This is a two-step problem. So we're going to have, on our flow chart, this next, liters, and for 1 mole here. Then we're going to have 1 mole on the bottom, and we're going to have 6.02 times 10 to the 23rd on the top because our problem says so, our flow chart says so. Multiply the two top numbers together, divide by the bottom number, and so like this, 2.58 second EE3 times 6.02 second EE23 equals, and then divide by 22.4, and we get 6.9 times 10 to the 25th atoms. Okay, Box our answer. Make sure that you cross off units as you go along. I just haven't been doing that, but you really should do that. It's good practice. How many formula units in 4.52 moles of sodium hydroxide? So we're looking for formula units. And we have 4.52 moles. And our flow chart says to put 1 mole on the bottom. And 6.02 times 10 to the 23rd on top. That's formula units. And perform that math. That's 4.52 times 6.02 second EE23. And that gives us 2.72 times 10 to the 24th formula units. All right? And box our answer. Let's go up here. Okay. Compound contains 15.3% sodium and 84.7% iodine. Calculate the empirical formula, and then calculate the molecular formula if the molar mass is 449.7 grams per mole. First thing you got to do is get the empirical formula, number 1. You take your percent of each of those elements and turn them into mass, and then divide. And this comes out to 0.67. When you divide this one out, it comes to 0.67. The next step is to divide by the smallest number. They're both the same, so we're going to divide by those. And that's going to give us our subscripts for our formula. And so our empirical formula is going to be NaI. We don't have to write the ones. Then what you're going to do is you're going to take the empirical formula mass, and it will be divided by, the molecular formula mass will be divided by the empirical formula mass. So 449.7 grams per mole divided by 149.9 grams per mole, and you're going to get the answer is going to be 3. Now you take that 3 and you put it on the outside of your, not carbon, but sodium. NaI, put that in parentheses, and multiply everything inside by 3. Your molecular formula becomes Na3I3. Okay, then the next one, 57.7 liters of nitrogen at STP, and you're going to calculate the number of moles. That's not so bad. So 22.4 goes here, and per 1 mole, and it's liters. Okay, so 57.7 liters divided by 22.4, 57.7 divided by 22.4, gets an answer of 2.58 moles. Okay. Station 5, 63.5 gram sample of diphosphorus pentoxide. Contains how many molecules? So we're trying to find the molecules here. And the molar mass is 283.89 grams per mole of diphosphorus pentoxide, so that's going to go here based on our flow chart. Then we're going to have to do this one more time. 1 mole goes here. 6.02 times 10 to the 23rd goes there. Multiply the two top numbers together, divide by the bottom. So we get 63.5 times 6.02 second E23. Get that number and divide by 283.89. We get 1.35 times 10 to the 23rd molecules, molex. All right. And what is the empirical form of a compound that is composed of 66 grams of calcium and 34 grams of phosphorus? Well, we need the molecular mass of calcium. That's going to be 40.08. And for phosphorus is going to be 30.9. Okay. We divide 66 by 40.8. 66 divided by 40.8 gives us 1.61. And 34 divided by 30, oops, let me do that again. 34 divided by 30.9 equals 1 point, oops, that's the wrong one. Jeez. 34 divided by 30.9. There we go. Oh, that's wrong too. How did that work out? There we go. I got to turn my calculator out. There we go. That's better. 34 divided by 30.9 equals 1.1. There we go. That's much better. Divide by the smallest number. Do that over here. That's going to give you 1.5. Can't leave it at a decimal, so we're going to multiply that by 2, and that'll give us a 3 for a subscript for calcium. Multiply that by 2, and that'll give us a 2 for a subscript, so we're going to end up with Ca3P2 for your empirical formula. Okay, last 4. How many formula units in 17.7 moles of titanium 3 nitrate? Okay, and so we're looking for formula units. Not a lot of room down there, so I'm just going to leave the unit off. I know I always complain about the units, but we're going to leave that one off for the room's sake. So we're going to put 1 mole here, and we're going to put the mass right up here. Not the mass, we don't need that. We need 6.02 times 10 to the 23rd. There we go, there's my train of thought. Okay, and that's formula units, all right? So it's a one-step problem, moles to formula units. So we multiply those two numbers together, 17.7 times 6.02 second EE23. We get 1.06 or 1.07 times 10 to the 25th, and that is formula units for your units, okay? We have a volume, we're looking for a volume, so we're looking for liters, and we're given 2.30 moles of oxygen gas. 1 mole down here, 22.4 liters here. 2.3 times 22.4 equals 515. Ooh, that's the wrong number. How did I get that? Jeez. Okay, not 515. Let's try it again. 2.3 times 22.4. 51.52. That's better. 51.52 liters of that gas. Okay. How many liters? Well, 35 grams. So we're going from mass, 35 grams, to liters, which is the way down here. So molar mass of C8H18 is 114.23 over 1 mole. 1 mole down here at the bottom, because our flow chart says so, 22.4 on top. So that's going to be 35 times 22.4 equals, divided by 114.23. We come up with 6.86 liters. Okay. How many grams of calcium carbonate in 3.62 moles? Molar mass of calcium carbonate per 1 mole is going to be 99.95 grams per 1 mole. And so we multiply those two numbers together. 3.62 times 99.95 equals 361.8 grams of that calcium carbonate. Okay, there's your review, and good luck on the test tomorrow.